So back to the last trend, the last periodic trend that your book talks about is something I can't spell, obviously. It's electronegativity. Which we're going to be abbreviating E-neg because it is so much shorter than electronegativity. And electronegativity is defined as the ability of an atom, of an element in a compound to draw the bonding electrons towards itself. Okay, period. We haven't discussed bonding yet, but a bond is, in the simplest form, a pair of electrons that is holding two elements or two atoms together. So say we have two hydrogens. Two electrons are going to hold them together, and since hydrogen is identical, each hydrogen is identical to the other, the electrons are going to be in the center of them. However, you could have a situation where you had hydrogen and a fluorine atom. Fluorine's a non-metal. Non-metals like to form anions, and it just so happens that fluorine's a very electronegative element. So when it bonds to hydrogen, the two electrons that form the bond are a whole lot closer to fluorine than they are to hydrogen, meaning fluorine is a more electronegative element than hydrogen. Okay, a thing to remember before we even talk about this trend is that nonmetals, such as fluorine, form anions. Okay, these guys really want to have the same electron configuration as the nearest noble gas, and to do that, they're going to pick up extra electrons. So oxygen O2 minus, fluorine -1, they're going to have the same configuration as neon. Metals, on the other hand, form cations. Remember, cations have positive charges, anions have negative charges. So sodium with 11 electrons and 11 protons wants to have the same electron configuration as neon does, so sodium is going to form a sodium +1 cation, and it wants to give up an electron. And that has a lot to do with electronegativity. What we find when we draw that periodic table again, first of all, we totally get rid of group 18. Group 18 is happy, it's stable, it has a filled S or filled S and P set of orbitals. It doesn't want any electrons. It doesn't want to give any up, it doesn't want to get any. But as you go across the periodic table from the metals to the nonmetals, metals wanting to be cations, these guys wanting to be anions, they want electrons, you're going to have increasing electronegativity. But you're not going to involve the halogens. We're going to stop at fluorine. Same thing is going to happen this way, increasing electronegativity. And we're going to see an overall diagonal trend heading towards fluorine. Fluorine being the most electronegative element you have. You actually have a table of electronegativities in your textbook. I'm not sure the page right now. And you're going to be using that to determine what kinds of bonds you have. But in terms of periodic trends in the periodic table, what you want to know is electronegativity is going to get bigger this way, bigger this way, bigger this way, with fluorine being the most electronegative element we have, and the noble gases are not involved at all. We'll talk about that more when we come back. Bye-bye.